Welcome to this explainer. Look, we are living through literally the fastest technological acceleration in human history. Today, we are answering one massive, unavoidable question. Why are humanoid robots finally stepping out of the digital realm to replace humans in the physical world?
You really have to ask yourself, right? How did we go from these clunky, awkward laboratory prototypes straight to the factory floor and, honestly, eventually into our homes? For decades, humanoids were these impressive tech demos that totally lacked real-world utility. But right now, we are witnessing this historic convergence of AI, advanced actuation, and perception. It's finally making commercial humanoid platforms an absolute reality.
So what's the actual catalyst here? Well, here is the absolute game changer. A staggering 40% drop in humanoid manufacturing costs in just a single year. This rapid price collapse completely obliterates the economic friction of replacing human labor. It's advancing factory applications by a full year and consumer applications by up to 4 years. To understand how this is happening, here's our roadmap for today. We'll start with why humanoids replace humans, move into the agentic AI brain, look at automating scientific discovery, accelerating medical breakthroughs, next-gen infrastructure, and finally, the autonomous horizon. Okay, let's jump right into section 1, why humanoids replace humans. Hardware accessibility is just exploding right now. Take the Unitree G1. It's hitting the market at around an accessible $16,000. That's a price point that completely democratizes robotics. And it's not just about cheaper hardware. The software is taking cues straight from nature. Using something inspired by the force ratchet teamwork of Weaver ants, we're now seeing multiple robots cooperate seamlessly on really complex tasks. Plus, as Harvard's Move Lab is showing us, wearable soft robotics are actively restoring mobility and independence for stroke survivors. Hardware is suddenly ready for the real world, stepping in to perform tasks humans used to have to do manually.
But a body is nothing without a mind, which brings us to section 2, the agentic AI brain.
We are officially waving goodbye to the chatbot era, where AI was just a passive assistant generating answers to your prompts. We are now in the agent era. Instead of just asking a tool for a quick answer, we are deploying autonomous systems with persistent memory. These agents can actually plan, reason, and execute complex, multi-step workflows with practically zero human oversight. And the market data reflects this transition perfectly. We're talking $37 billion being spent on enterprise generative AI by 2025 alone. Just look at Anthropic. They now command 40% of the enterprise large language model market. Meanwhile, disruptors like China's DeepSeek are proving something absolutely crucial. Highly capable AI brains known as small language models can operate on just a fraction of the usual computing resources. Why does that matter? Because it means these highly efficient brains can be deployed locally, entirely off-grid, right inside the physical bodies of those humanoid robots we just talked about. This totally reshapes how we do research. Let's move to section 3, automating scientific discovery. We are seeing AI basically step up as a co-scientist. AlphaFold 3 is now extending its structural prediction capabilities all the way to DNA and RNA, while Google's Deep Somatic AI is identifying genetic variants directly in tumors. And on the hardware side, engineers have actually constructed fully programmable autonomous micro-robots measuring just 200 by 300 by 50 micrometers. That is literally smaller than a grain of salt. AI and robotics aren't just processing data anymore. They are physically taking over the painstaking manual labor of laboratory research. And this computational power extends way beyond the microscope to our planet's most complex systems. AI models like WeatherNext 2 are crushing computational bottlenecks, generating crucial weather forecasts 8 times faster than traditional models. This means predicting life-threatening weather events with pinpoint 1-hour resolutions. It's keeping human populations safer than ever before. Which naturally leads us to section 4, accelerating medical breakthroughs. Now, all this incredible speed in the lab would be totally useless if we couldn't get it to patients, right? To keep pace, the FDA is radically ripping up the red tape. Through their new plausible mechanism framework, developers tackling severe genetic conditions with a known biological cause can apply individualized genome editing or RNA therapy and actually bypass those traditional, lengthy randomized trials. By generating clinical safety data based on known biology, this pathway accelerates safe therapies to market for rare diseases exponentially faster. And this regulatory shift? It pairs perfectly with new diagnostic AI tools like Harvard's PopEve model. This AI makes the identification of specific disease-causing genetic variants nearly instantaneous.
When you combine rapid AI diagnosis with these accelerated FDA pathways for customized gene editing, you are looking at a total revolution in personalized medicine, completely replacing the need for agonizing manual human analysis.
To support all of this, we need a new foundation. Section 5, Next-Gen Infrastructure. You literally can't have this level of global automation without an entirely new backbone. 13,000 times faster. That is the verifiable speed advantage Google's quantum echoes algorithm just achieved over classical supercomputers when computing complex molecular structures. We are rapidly moving from physics theory to engineering reality here.
To really wrap your head around this quantum leap, a molecular benchmark problem that would require a classical supercomputer 10 to the 25th power years to calculate, which, by the way, is longer than the lifespan of the universe, takes the new quantum Willow chip just 5 minutes. By using advanced error correction, they are knocking down the ultimate barrier to practical quantum computing.
Meanwhile, our communications infrastructure is completely transforming to handle this massive computational load. 6G networks are utilizing what they call semantic planes to transmit the contextual meaning of data rather than just raw bits. Through integrated sensing and communication, the telecom network itself basically becomes a giant radar for tracking physical objects. And aerospace engineers, they're actively designing solar-powered AI data centers to operate in the freezing vacuum of space. This isn't just the internet anymore. This is a sensory nervous system designed specifically to support billions of autonomous physical machines down here on Earth.
And finally, Section 6, the autonomous horizon. This is where the convergence of human and machine gets incredibly real. Brain-computer interfaces, or BCIs, have exploded into clinical reality this year alone. In early 2025, Precision Neuroscience secured FDA clearance for an ultra-thin brain film. By mid-year, Neuralink patients globally were controlling computers with their thoughts mere hours after surgery. And by late 2025, Columbia University unveiled a single-chip BCI establishing high-bandwidth wireless communication directly with the human brain. Of course, as neutral observers have pointed out, this raises the ultimate philosophical hard problem of consciousness. When our actions are mediated through algorithms that interpret our neural signals, how do we assign responsibility? It forces us to ask some really deep questions about personhood, privacy, and identity, as the barrier between our physical minds and the digital ecosystem effectively vanishes. So I really want to leave you with this thought to ponder today. If agentic AI and humanoid robots truly remove all human friction, what happens to human agency in a perfectly autonomous world? As machines literally step into our shoes to execute our physical tasks, what new paths will humanity choose to walk? Thanks for joining me for this explainer. Keep questioning, keep learning, and I'll catch you next time.